Hi, I'm Konrad Konarski. I'm the Senior Practice Head for Artificial Intelligence and Internet of Things at Vsoft Labs.
Our panel discussion is moderated by Konrad Konarski, who is a successful entrepreneur, engineer, business professional, and thought leader, possessing a unique holistic perspective on delivering AI solutions that bring tangible value to customers for close to 2 decades. He is currently the chairman of the AI Innovation Consortium and the VP for AI and IoT at Vsoft Consulting, where his cumulative expertise helps commercialize and deliver industry-changing solutions for various vertical markets. Konrad, thank you so much for being here and moderating this panel for us.
Thank you, Shannon. Thank you, everybody. Luckily, I can't see any of you with the light on, so if you raise your hand, I won't be able to see. So feel free to reach out after the presentation for your questions. So today I have, I think, a really interesting, diverse panel. I wanted to start maybe to give you a little perspective about the consortium, since Shannon already introduced me. So, you know, unlike the Industrial Internet Consortium, which, by the way, was a great presentation, we really focus entirely on artificial intelligence. We have, I think, 2 very tangible things that we do that are relevant to the audience here. We have an incubator lab for manufacturing out of Penn State University, and we have an AI digital oil field lab out of the University of Houston. So if you have time after the panel here, you can Google both of those, AI Innovation Consortium and those 2 labs. They'll give you a flavor of what we do there. And the lab in the University of Houston is actually 4,000 square feet. So it's a pretty massive lab in which we do a lot of artificial intelligence work. And like I mentioned, you know, we do this sort of thing pretty often, and these individuals are part of the ecosystem of the consortium. But I think the uniqueness of our panel here today is we have a lot of diverse roles, a lot of grassroots roles in the manufacturing space. So I'd like to present to you their perspectives. We have 5, maybe 6 panel themes that we'll go through today. And if we have time, we'll look to engage you guys as well on questions that you have to the panel. So I want to start by having everybody introduce themselves and their organizations. And one of the other things I want everyone to do is define what artificial intelligence means to you specifically in your role. Because I think, you know, we've heard different definitions, we've heard the technical definitions, but I think from an operations perspective, from an enterprise analytics perspective, that definition and the value of AI is different. So maybe Chris, you can start.
Sure, my name is Chris Andraka. I am the Senior Maintenance Manager at Goodman Manufacturing, where we produce HVAC, so furnaces, air handlers, and condenser units. Whole background's always been in manufacturing and maintenance, and to me, AI it's the future. I mean, we need all the data we can get to do all the predictive maintenance that we can to make sure that our machines have 0 downtime, which is, of course, the goal. I've worked in old factories, so 40 years old at Continental Tire, now at Goodman Manufacturing. It's a relatively new facility. However, it's got a lot of old technology that was brought from the 4 other plants that it was consolidated into. So I'm really excited to actually get the AI brought into the factory to bring it to really the now and the future.
Thank you, Chris.
All right, I guess I'll go first. Let me grab some water. I'll go next. So my name is Elias Brown. I work for Vallourec at their corporate office down in Houston. I lead industrial data analytics for them. And we have many plants around the country, and actually one of our managers, our general managers out of the plants was going to come as well. Unfortunately, wasn't able to make it. So what AI means to me, among many things inside of a manufacturing, from a manufacturing perspective in particular, I think is really utilizing or harnessing technology to improve efficiencies and performances within our mills and different divisions around the country. There are a lot of different aspects to that. I mean, whether it's allocation, capacity, demand planning, routing, all sorts of things. But it's really leveraging the technology that we have today and in the future to improve those. So.
All right, so my name is Justin Kubu. I work with Inland Pipe Rehabilitation, which is a CIPP cure and price pipe trenchless rehabilitation company. We service the entire United States, but primarily located eastern all the way out to Colorado. I'm the technical operations manager for our company, specifically in the manufacturing division. And what AI means to me is, as far as quality control and assurance, obviously with our product being utilized in like utilities and wastewater, potable water, so the water that you drink, we're replacing all the pipes that only have like a longevity of anywhere from 10 to 15 years, and increasing that longevity with a nice solution for not having to dig up 5,000 linear feet of pipe and get underneath all these old buildings that have old pipes. So quality is near and dear to my heart. And just a little bit of background, I'm only been in this type of industry for a little over a year. As far as AI is concerned, like I am very, very much into this, and the biggest problem set, which we're going to get into, in my eyes, in my opinion, is what was brought up in the last presentation of known unknowns. So defining the problem so you can come up with that solution to wherever industry you work for is extremely critical, but defining those known unknowns is extremely critical, in my opinion. I'll pass it over to Konrad to start it off with a question.
Thanks, Justin. So we have one other person that couldn't make it today, David Crawley. He's a professor at University of Houston. He's one of the kind of prime contacts we have out of University of Houston that works with us in the AI lab, so he would create an academic dimension, but unfortunately he's not here today. You had a great kind of lead into the next question because of the conversation we had earlier on barriers of adoption and challenges, right? So I think you represent the next generation of workers that have technology really as part of their fingertips, right? And a lot of the challenges that you deal with are related to people that maybe question not just artificial intelligence, but are, for lack of a better word, like old school, right? And one of your challenges, as you kind of communicated to me, was that you have to convince old school frame of thought that technology can benefit you, and artificial intelligence being an emerging technology is part of one of the most difficult things to convince, right? Because it's not yet an established, pervasively available technology in the manufacturing space. So I'll work backwards from you, Justin, and you guys can have that great conversation you had in the coffee room there. What are the barriers and challenges, part of what I mentioned just now and others, to artificial intelligence adoption in manufacturing, and how do you foresee that we can solve those problems?
So I'll start it off and then I'll pass it over to Chris, because Chris and I got pretty into this in a good way, because discussion is what's going to lead to the future. So the problem set that I have in my company is a lot of old school mentality, and I'm not saying that for the people in the room that are beyond the age of 50. I apologize, I'm not trying to be offensive.
You had to pick that age very carefully, right? You looked around to see how many people you would offend.
But what I've learned in my experience is, people are always stuck in their ways, and if it works, if it's not broke, don't fix it. But that doesn't mean that you can't come up with a solution and be innovative to improve a process or to have a higher level of quality. So specifically in my market research, in my niche industry, I've found that none of my competitors are pushing forward with AI with their quality control and assurance checks. And I've been working intensively with Konrad, with the University of Houston and Penn State, because I have a very unique problem set. And my bosses understand that there is a unique problem set. However, there's kind of stuck in that niche of, why do we need this? Why do we need this technology? Why is this important? Why do I need to spend hundreds of thousands, if not millions of dollars on this technology? And I think it's like, this is the way of the future. And like cell phones, if you look at 1995, there was probably a percentage that had a cell phone. Now, if you don't have a cell phone, I don't know where you're doing, what you're living, but it's part of the norm, and that's where I think AI is heading. And I'll kind of pass it over to Chris, because I think he has a very similar problem set ahead of him, like many of us, which is convincing that old school mentality that AI is innovative and it's part of the future, and it's not necessarily in one specific niche, but you can apply it to many different problem sets as long as you define those problem sets clearly and articulately.
Yeah, and I completely agree with you. It's overcoming that challenge of management and some of the longer-term employees and managers that are in the facility have done their manufacturing a certain way. They've done all the manual data counts, they've done all their manual processes, and well, they didn't grow up with technology like a lot of the new generation coming up in management. So we've got that almost trustworthiness challenge that we have to convince that, hey, this machine can tell us exactly what's going on with it. We can see, hey, the RPMs are not okay on this motor, it's drawing way too many amps, and we can predict failures well in advance of them actually happening, versus the operator who's been working there for 40 years saying, hey, this doesn't sound right, I think the belt's a little too tight. So that's one hurdle. The second hurdle, I think, is definitely a resource, whether it's time or financial. We do have to convince, like I said, management that, hey, this is worth it. It's worth the risk that's involved with spending $500,000 to $1 million a year getting a factory such as Goodman, which is a 4.2 million square foot factory, into the digital age. And then on top of that, being able to show, okay, you invested $1 million, well, here's your return. We had 0 breakdowns on this assembly line for a period of 24 months. And that is certainly a challenge I see going forward. So.
Yeah, and I think kind of piggybacking off that, so there are a few challenges I see here. I think one of them is buy-in, definitely. And I think another one is, even after you get that buy-in, I think there's some significant hurdles that take place. So especially when you're talking about industrial analytics in particular, you can get that data, but now you need to make it useful. And so that's one of the things that becomes more difficult. You can, gather all of this data, but how do you harness it? And so that's one of the things that we in particular, I'm just trying to come at this from a little bit of a different angle here, I guess, but one of the things that we in particular run into is we have all of this data, but how do we make sure that it's all in the proper format, that it's all clean, that we're able to actually put it into models or actually run analytics off of this? Because some of the things that are really important, I think, especially going into the future, are, like you said, predictive maintenance. How do we actually, how do we run our routing and our allocation? But you have to have all of that data, and it has to be clean. So you hear this a lot, but data is definitely key here, I think. So.
And with that, the ability to automatically analyze it too. So right now, I know a lot of the data is being manually analyzed. I personally, every day, look at the data and say, okay, where is our biggest impact to the production? Whereas if we could have something automated, something artificial intelligence to say, hey, you've got a problem on this assembly line, on this machine, specifically at this station, go and fix it, rather than spending that first hour to 2 of the day investigating where those problems were for the previous day.
Right.
Yeah, I think that ties into like trends analysis, so that you can do that preventative maintenance checks for the assembly line before it gets to that quality check, that final stamp of approval, hey, it's ready to go to the customer. And I think one third thing, in addition to time and money, is technology, because technology is ever growing, ever changing, ever evolving. And you may think you have the Denali of AI software, but next month that is outdated, just like your phone. People wait in line for the iPhone 13, iPhone 97X, whatever is out nowadays, and next month that is obsolete technology. And I think that's a hurdle that has to be presented as far as a known unknown, as far as the technological advancements and what's readily available to us as consumers. And one subject I've kind of broached with Konrad is the readily available technology to us as consumers is so purely different to what's available to the government, which is where I came from prior to moving into this industry. And I know that the government holds close tight to themselves technology that's ahead of its time before it's ahead of us as consumers.
Let me throw a few more problems in the bucket, and let's talk about the solutions. And again, I'll maybe throw another lens at this as well, right? So as part of the consortium's efforts, one of the things we have is a manufacturing sub-council, and we talk about like relevant barriers, like exactly what you guys said, right? And then depending on the roles in the people that are participating, sometimes we get operations people, sometimes we get data scientists, and I heard something that is a very relevant point twice now. I think you said it with the data, and they need to be able to consume that data and make it relevant. And also, I think in the keynote it was mentioned, but I will say sometimes data is not available. I know we hear a lot about how much data we have, but I use that example specifically in one of both of your use cases, in effect, is in computer vision, where you're looking to automate quality inspection. Sometimes you need representations of those visual defects. And the reality is, and this is something that's resonated in manufacturing and oil and gas, is we may have terabytes of data, but that data is useless for our use case. We need to start collecting new data and capturing information in shapes and forms that we've never thought of. So that's a challenge, having enough data in some cases, not just having too much of it. I went the other way. The other thing is, and then this is kind of resonating with general themes of the untrustness levels of artificial intelligence in different shapes and forms, is transparency of AI. So in that discussion that we had, one of the things that I've heard resonate is like, this model is now taking over my quality inspection and coming up to me with a result that says pass or fail. But I have no understanding of what's inside. Why is it coming up to those conclusions? These are deductive logics that normally a quality inspector can write down on a piece of paper. So building frameworks, best practices, and providing algorithm and AI transparency, and having the frame of mind of, well, that AI is now essentially taken over a task that was an operator, potentially. You need to consider these dimensions, I think, of barriers, right? So I wanted to ask you a follow-up question on convincing people that it works. Like, what does that take? Is that a proof of concept? Is that a value case? Is that sitting them down to show them it working live? Where do you see, and how do you see being able to break executive management's perspective on certain, call them closed-minded or whatever, perspectives on how old school works and new school doesn't?
Well, certainly part of it is that use case. I mean, we're implementing at our factory just very small bits at a time. So we'll take one machine, or in the example that I'm working on with you, Konrad, is the tool and die area. We've got a visual system that we're taking a picture of the die during a material change. And it's a very small focus area, but it's something that once we prove it works, once we prove that to the operators that, hey, this is not taking away your job, this is helping you to do your job more efficiently, helping you to do it, especially in today's labor shortage that we have. You don't need 3 people to do this. You can do it yourself, and we can still work on getting you those additional resources and time. And then proving to management that, hey, we've been able to implement this vision system for this one aspect. It's reduced our die crashes and therefore our downtime. We've been able to output more product in the end, and a higher quality product, because you're not going to have holes mispunched in the sheet metal. You're not going to have wrinkles in the sides. So I do think that those both play a role in it, both to the operators and technicians, as well as to the management.
I will say we're perfectly segueing from question to question, because the next question is share a little bit more about what you're doing with artificial intelligence as part of your role, your organization, your vertical market, either today or in the future, what you plan to do. And you shared a little bit about that, so we'll go to Eli, and we can come back if you have some more to share.
Okay, sure, absolutely. So currently, from a North American corporate perspective at least, when it comes to industrial analytics around the region, right now, currently we use some AI for forecasting, financial figures. We also use it for allocation around the region, routing and demand capacities from different facilities around the region. And it's extremely helpful. I mean, this is going from people doing things on pen and paper, and someone sits down for a week and writes all this stuff out, and they're trying to determine what the best case is, to actually taking in information from people around the regions and being able to take this data and run it through our systems and actually come out with an answer that is much faster and much more efficient than the way it used to be done. And so those are some of the things that are being done currently, but also in the future. I mean, we hear this a lot, but predictive maintenance is going to be. Predictive maintenance is one of those things that will help us in particular to save money and efficiencies, right? So we don't have downtime, but this is one of those things that it's going to take us. It takes a while to get the equipment set up because a lot of these plants are very old, right? And so you have to get these IoT devices out on the edge to actually be able to monitor this stuff, take in this information, and then utilize it. So that's kind of where we're heading. It's one of those things that we want to actually bring into our facilities, as well as being able to take failure,
I want to go back to actually, so that I'm going to interrupt you. I forgot.
Yeah, sure, go ahead.
Enterprise analytics, like
Sure.
you lead this as part of your role in Vallourec, right? And you have a platform that you use, and this is kind of, I think some of you folks, right? You've heard about data analytics. It's nothing new, right? So what is AI versus data analytics to provide some sort of information to your organization? And what does that do? So, and I'm going to let you piggyback off of my thought process. Sure. Artificial intelligence, from my lens, right, it's about being able to consume natural language data, for example. NLU, natural language understanding, is a form of artificial intelligence that can interpret large volumes of textual data and then provide you insights, which is something really statistically, if you're doing analysis, unheard of in traditional statistical analysis. You can't look at maintenance notes and then determine over 1 million entries historical significance between maintenance orders and failure of a system. So, and we had this conversation offline. Part of what you do is try to find new data within the pool of data that you have and run statistical analysis on it in different ways to provide different dimensions of insights to your organization, right? So do you think that, with the evolution of self-service tools, because you're a data analytics person, like you don't know the insides of an AI model per se. I'm not trying to, I know your role, right? So do you think that will be useful? And maybe elaborate on how that would be useful for operations and for executive management.
Yeah, so one of the things you don't want to happen is you don't want information going into a black box and then something coming out on the other side and nobody knowing what happened in the middle. So having AI models to actually analyze this data and give you some sort of result is great. I think that there needs to be not ambiguous, right? There needs to be some understanding of how that actually works and what it's actually doing. But yeah, no, absolutely. I think that this is stuff that is absolutely helpful, and it's stuff that's going to come in the future. But you need not only a lot of data, but you need the right data. And so one of the things that we run into a lot, this is kind of a problem, right, is that we'll have the data, but maybe here we'll use metric tons, maybe somewhere else they'll use a different measure for weight, right? Or we'll use feet, somebody else will use centimeters, inches. I mean, it's complex, right, for the different mills around the globe. And so one of the problems that we have is we wind up having this kind of ambiguity within our data between the different ways of actually calculating and making these measurements. And so you wind up having a lot of data that might not be useful to be. So
there's a lot of manual work that you have to get to before you can make it work? Is that what it is? Like, do you not have enough tools available to you to make that automated, let's say?
I would say currently that's the case. And so one of the things that's really important here is actually taking these systems and aligning them at either a global or definitely at a regional scale, and making sure that information is coming into where it can be put into a model, and there can be a process put in place so that people understand how that works, and you get your results on the other side.
Justin, hey, how's it going?
Howdy. So, I'm glad that you brought up about the data capture, and I think what you're attesting to is like volume, and I think it's taken in phases. So like phase one is you start like with a small sample and get that proof of concept to understand the holistic problem set that you're trying to solve. So starting very small and then gradually going up to the max capacity. So like with Penn State, working with them about sending them 3 5-foot sections, and then in phase 1 alpha, it's 3 5-foot sections that are labeled. Then phase 1 Bravo is 3 5-foot sections that are not labeled to test the system of the vision, both the hardware and the software, to be able to properly detect. Like I mentioned earlier, I'm focused right now as far as my AI implementation plan for my company is just focusing on quality, and then going to those next steps of trends analysis so I can do some predictive maintenance and predictive analysis to the fabrication lines and be like, hey, I noticed the AI learning model noticed that last week there was an increase in stitching errors. There was a decrease in tape errors. Now, why is that? And then that is like phase 6 of my AI implementation plan. But phase 1 is obviously gathering the data and then starting out small and then working bigger, and increasing the amount of volume so that the AI can understand what it's actually looking at and then move forward for the trends analysis. And I think that's just piggybacking off the implementation.
Right. And so I kind of hear the same thing from Chris as well, right? When it comes to the approach, discrete baby steps. I heard that actually in one of the frameworks that was shared by our keynote. You want to start small, simple, valuable, low-hanging fruit opportunities to show value to your organization and scale from there. And I think especially with AI, the capabilities of what computer vision, as one example, NLU processing as another can bring, once you prove that out, I think you open a floodgate of opportunities with quality people that have been working with traditional hardware vision systems that have heuristic rules. I wanted to kind of throw this into my intro, but I didn't get a chance. For example, with AI computer vision, which is a very common application in the manufacturing space outside of predictive analytics for quality inspection, what that brings to the table is essentially the ability of that neural network to have infinite permutation of understanding of a surface area, whereas most of you, if you've worked with computer vision systems, it's heuristic rules. I can see something that might be wrong here. I'm not sure if it's wrong. And hey, if my lighting changes or if my production line chemistry somehow change, that may not even be detected anymore by these heuristic rules, and I have to reprogram. And I heard that also in our conversations. Like some of the issues with traditional hardware is I have to change it too often to align to my production line, right? So AI gives you that dimension of learning as it goes and being able to address changes in production, lighting conditions, things like that. So again, a nice perfect segue. So this is so the next question, and it's call it a very open question, and maybe I'll lead with the discussion, is what do you see AI in 5 to 10 years? And depending on audience and depending on how I feel that morning or that afternoon, I guess I always say something a little bit different because it's from a different dimension. I wanted to cover it in a few dimensions today. One is kind of technically, right? There is a lot of evolution of out-of-box tooling and hardware in the market space. At the grassroots level, edge computing devices. Even if you've read recently, IBM, I'm actually a former IBM, came out with analog computers that are designed specifically to be able to handle particular types of neural networks, meaning that they're designed for particular use cases, potentially, right? If there's economies of scale, maybe not, right? Neuromorphic computing is another one. Quantum computing, of course, the mathematics in quantum computing or vector mathematics, so perfectly aligned for neural network training. And in fact, we have things in our consortium lab. NVIDIA, which is a large GPU manufacturer, donated one of their supercomputers to our high-performance lab, and we use that constantly for model training. And model training on large amounts of data is time-consuming, and if you don't have that type of hardware accessible, it's an issue. So I think the evolution of these hardware technologies will make AI more prevalent, more powerful. I'll say, I think the out-of-box service tools. So Eli, not having an AI model specifically accessible to you for particular consumption of input makes it so that you have to rely on those traditional tools that are from an undisclosed enterprise analytics tool that I won't mention, that I know of, aren't necessarily available to you, right? So I think those will become available, and then data scientists will be able to adopt them. I think the other thing is the advent of scalability of the technology. So, we're looking at this from the lens of operations, management, but from the lens of a CIO, how do I scale this technology to 10,000 systems, right? So there's the need for platforms to be able to coexist with edge AI systems, edge IoT systems, and that line between AI and IoT is also blurred. Like even fundamentally in the keynote, we kind of heard that, right? Like edge IoT devices have the ability to make decisions, and those are really just artificial intelligence decisions. Those will become much more pervasive. I think also there's evolutions of like neural networks. Like one of the challenges to not having data is to actually be able to use neural networks that can train on very low amounts of data and still be useful, so that you can stand them up quickly. So reducing the time to go to deploy, because it's the pretty time-consuming, and we talked about this, time-consuming, custom kind of process today, whereas in the future that won't be the case. And of course, there's the whole, Terminator 2, Cyberdyne thing, but we won't get into that today. So how do you guys see the future of artificial intelligence 5 to 10 years, and feel to speak in any order you like?
So, I mean, I see the AI moving in the next 5 to 10 years, and the biggest problem set that I have right now is primarily human error. I'm not trying to eliminate laborers. I'm not trying to eliminate the workforce, but I'm trying to, like Eli was saying, like improve the efficiency of that worker and alert them, be like, hey, you missed this, because, we as humans, we have 6,000 things going on in our mind. We've got family problems, we've got finance problems, we've got, political problems that we're constantly worried about. And I don't think that there's one person that's ever laser focused on the job at hand, because they've got so many other things going on. So I think that AI can aid that worker with getting their job done right the first time. And then I think going to the next step is all those communicating systems, that IoT, where it's like the AI at the quality assurance is saying, oh, I see this. It's going to talk to the fabrication line 1 and be like, hey, what did you do? What did you change? Oh, and the fabrication line's going to say, oh, I need to change that. You're right. Thanks for covering my back. And I think that's like, not to get into the Terminator 2 kind of mentality, but I think that's the future, is like all these systems are interoperable and they're talking with one another. And ultimately, it's like they're watching each other 6, so that when it gets to the final product or final service that they're providing, it's completely automated and it's completely taken care of, and it's eliminating human error in its entirety. Again, not to eliminate workforce, because that's obviously going to be a necessity until the Terminators do all the work for us.
Cobots, right? Collaborative bots. Industry 5.0, yeah.
And to piggyback off what you said, not only is it, you've got humans who are interacting it, and there's fatigue there. So if we can eliminate stress from people's jobs, eliminate maybe even the need to work 8 hours a day and reduce that to a 4-hour or a 6-hour workday, where the operators can maybe just monitor even from home, or a technician, and allow that factory to run itself. In the next 5 years, I really see a lot more AI integration with the operators. And then maybe in 10 years, we can see even more dark factories. I know there's some in existence now, but there's a limited amount. I do see in the next 10 years that we'll have completely automated factories where you have some key decision makers, technicians who are there to fix issues that come up that are reported maybe via email or a text message, and they can just show up to work when those issues do happen.
And so I think in the next 5 to 10 years, well, it really starts today, right? So if you're putting sensors out, like let's say out in the field, right? So today you put sensors out at a valve, or put sensors out on a pipe flow meters or something, right? And alert the operator for some situation, right? So instead of them having to go out and check, you have a sensor that's able to alert them of this, right? These systems kind of build on each other. So we might have that today, and then we start expanding that, and that information starts coming up to your analysts, right? And you're actually able to take this information, and maybe if the flow is too low in this area, it's going to affect something downstream. And so then you're kind of getting into the maintenance end of things, right? And so today maybe we're putting in those sensors, but in the next 5, 10 years, maybe this actually starts to, the hope is that really expands into more quality, safety, and maintenance efficiencies, right? So we're really able to take this information and leverage it to do predictive analytics. That's the whole goal, right? We don't want one of our lines to go down because something broke, when we could have just checked a sensor that's upstream that says, hey, if the flow is too low, it's going to break this pump because there's not enough pressure, right? These are things that are predictable if you have the right equipment and you have the right information coming in. And so I think that in the next 5 or 10 years, we'll really start to see a lot more of that. Dark factories, we'll definitely see more of that in the future as well. But I think it's the little things, and I think they'll really start stacking. The biggest thing is having buy-in and starting to build this information.
Maybe 5 years, that question is meant to be kind of generic, but let's speaking of the future, the near future, right? Like predictive analytics using physics-based AI simulations. I'm sure some of you may have heard this, right? So traditionally, if you've been working in predictive prescriptive analytics, you are using data points from your IoT grid for rotation, speeds, temperature. A lot of the next generation things that are happening today with artificial intelligence for predictive analytics is actually modeling the mechanics of the machine that you're working on or with, and using that as input to your AI in addition to the sensors, because those are sensor points that you really can't get with traditional IoT technologies, but you can bring them in a simulated way, like a digital twin way. I will say, I'll anecdote all this by saying, we kind of threw the Terminator, I threw the Terminator 2 analogy out there. But the reality of the investments in large tech today is not to replace workers, but to augment their ability to function. Like if you look at all the top tier IT technology companies in their AI cloud, they're offering tools to help with the operators to be able to do something, to consume data, to analyze data. And also fundamentally, and something that I've heard time and time again is, domain experts are those quality inspectors. They're the ones that will train that AI and supervise the AI. So it's not intended to be something that, it's intended to redirect resources, potentially automate and help, speed throughput, but not really necessarily replace operators, right? They're still fundamental to the process of getting the job done.
No, I mean, I think you're absolutely right. You're redirecting the resource because AI for me specifically, and I think with Eli, is freeing up your time to solve other problems, because there's always going to be a problem that needs solving, and this is just one avenue of approach that we can take as a community to free up our time and do less data analytics behind a computer and an Excel sheet and solve other problems, which is what we do. That's our goal.
And I think that's a really good point. Something that's extremely important is, especially for if you sit behind a desk, right? If you're kind of tucked away in the broom closet doing analytics, something that's really important is having those subject matter experts that are out at the plants that run this process, right? So having their input on how this actually works, what the checks and balances are with this equipment and with this process is extremely important. You can't do one without the other. And I just think that's one of those points that's really important when you start talking about implementing this stuff, is actually going out and talking to the people that do this every day, right? In order to implement this stuff so that it functions correctly. That's one of those things that's just paramount to the success of these type of initiatives, to be completely honest.
Yeah, not only just talking to them, but showing them once it's implemented that, hey, see, this is making your job easier. This is meant to supplement what you're doing on a day-to-day basis, not to just completely replace you.
No, and I'm glad you brought that up, Chris, because one of the problem sets that I have with my employees, the subject matter experts, is they're a lot younger than I am. So they're always attached to their phones, and they're not necessarily always, like I said, laser focused on the task at hand. But this is a technology or a process that can augment them, and all I'm looking for is a visual and auditorial alert. Be like, hey, there is a defect, you need to correct this. I'm not looking for the AI to correct the defect. I'm just looking for them to be like, hey, you have this coming up in 10 feet. And then it automatically stops the line, and then they can do their thing and then hit a button and go again.
So no taser anymore then?
No, take that out.
Okay. The last question is probably my favorite. It's kind of a generic question, but it has a lot of value, I think, individually to each of us, is what individually do you want one thing that the audience takes away from your panel position here? What one topic, one theme, one sentence, if you will, that you'd like our audience here to take away from your panel discussion? And who wants to go first? I can see all you guys are volunteering.
So I'll go first. I think it's the one sentence. I say it's define the problem and your current situation, and then develop an end state. What is your end state that you want in your industry? And then that's how you spell it out. And you list out all the known unknowns, you list out all the unknowns, and you come up with all the different operational variables, and then present the solution a feasible, acceptable, complete, distinguishable solution to the powers that be, the head honchos, the old school mentality that this is the future.
Yeah, no, I think that's very true. I think another thing that's really important, I'll keep it short and sweet, I guess, but is governance, especially from a data analytics perspective. When you're talking about multiple facilities around a region or multiple regions, having governance over this data, knowing what's coming in, is it clean, how's it put together, can we put this all together in one place, and preparing it for these models is really important. So I think, of course, buy-in and all of that is important, but I think governance, having a good idea of how to actually govern these.
I won't mention this now, but now with AI, your data steward will be the AI. Think about that.
There you go.
That's a different conference next.
And for me, it starts small. I mean, a lot of us work at larger facilities, larger factories that are 30, 40 years old, or 19 years old, I guess is the average. But start small. Start in one area that maybe costs less than $100,000 to implement on one machine, and then prove that it works. Show the operator, show the management that this is how we can get to the next step, and then start rolling that out one machine at a time until the whole factory is then integrated into that AI and automated system.
That's a good one. I'll say, I think, I thought about this, and I want to maintain my answer sort of consistently from each of these. Start now. Like I've been at several of these. We've had our own in the past. We're not an event company, but we had our own kind of event, and it's the same general theme and same questions that come up. Even if you don't want to start, diving into the pool, there's simple things that you can do today. One of the things I mentioned is if you have a use case that demands relevant data collection and you don't have that data, start collecting that data. It's as simple as setting up a camera system with the right sort of setup to be able to collect that information for your quality inspection. Start looking at the use cases in detail and articulating and understanding the value of them. There's a theme, I think it was originally established by Gartner called Infonomics, which is the monetization of data and how it becomes an ever important tool in staying competitively advantaged against your competitors. I've seen in our manufacturing council, even some people that are not here, but they were supposed to actually be here, that are shifting their business model to be a data-driven organization from a manufacturing one because they understand that the shift in global economics will make them obsolete unless they can start selling information alongside their product. So those are strategic, important things that if you don't start doing now, you will be too late by the time it comes around to being forced to do it. So start today. So we have actually, I don't know if we have 25 minutes, I started late, but we have roughly 15 minutes. So I wanted to allow you guys, if you have any questions to our panel, specifically, or to all of us, to get a chance to ask them, because I think that's a nice interactive way. We're all friendly guys here, so we'll answer them as best as we can. Does anybody have any questions that they'd like to ask?
So, how important would you say, how important would you say it is for a company that's just getting started, maybe they're a little late getting started on their transformation journey? How important is it for that company to partner with other companies that are going down the same path? Maybe somebody's already ahead of them, maybe somebody's behind them. Just want to get your thoughts on that.
So I'll let the panel answer because my answer will be biased. I will say one thing though. One of the things that we do in the consortium is federated learning models where we're looking to collaboratively bring industry together so that those AI models are not just a function of one data set within the industry, but the entire industry, as far as we can make it happen, right? Like oil and gas is very tightly knit on seismic and other data, but more open on health and safety applications of AI, right? So it's important, but I think the best people to answer here are the people that are in the trenches with you, right? So
I think it's personally extremely important to get other companies, other individuals in the area involved. There are people who are going to have ideas that they've already started. They could be something that they're stuck at a roadblock, and you can actually offer some support to as well. So getting that network built and speaking with other individuals, other companies, seeing what ideas are there is extremely, extremely important.
Yeah, and I know you're talking about starting late or, maybe starting fresh even. So I guess there are a few different things there. I guess I'll talk on both of them. One is if you're starting from the very beginning, that's the easiest, right? So as from a data analytics perspective, you can start collecting data immediately, right? So setting up those systems correctly in the first place is important, and so that's something that you definitely want to collaborate on. But if you're like us and you already have all of these plants, these facilities, and they have all this data, and you're trying to figure out how to get it all together, it can be much more complex. And so finding other people and collaborating with people that have already done or have systems that are already doing this is really important too. And one of the best ways to do that, I would say, is being part of the, coming into the conferences, being part of the consortium, talking to other businesses that are in your field. But that's just from me. I don't know, Justin.
So I have two trains of thought. I have one train of thought where I agree with both my other panelists that it's extremely important, but the other train of thought is OPSEC, operational security, for what I'm doing and have that competitive edge, and I have the potential to lose that competitive edge because I don't know where that other industry's network extends, and that may extend to my competitor. So I see both sides of the coin.
And that's diversity right there, right? Any other questions?
I'd like to know more about the underlying data acquisition and data quality. How much of that is prior to the AI project, and how much of that evolved side by side as we are working with the AI?
You want to go first, and then I can. You're the enterprise analytics guy.
I'll go first. So that's a really good question. So how much of that was an effect of actually starting into our AI journey, or how much of that was already being done? It's kind of hard to say. I mean, I would say a lot of it was due to seeing not the complexity, but the amount of clean information that's required to do some of the analytics that we wanted. So we as a company, we recognize the fact that data is extremely important. In fact, data is the most important asset that any business has, right? Data is the most important thing. So getting that in line to where you can start running analytics, whether it's using AI or not, is extremely important. And so that's one of the things I think we recognized and have started really leveraging. And then once we were able to recognize how we could actually utilize AI within the business, it just incentivized us that much more to make sure that we're putting these quality checks in place and getting good information. Because like I had mentioned before, we have all sorts of stuff. When you have multiple different facilities around the region, you get all sorts of different information from all sorts of different people, and ensuring that it's clean, it's timely, and it's accurate is extremely important. And so putting those in place as soon as possible and in an effective manner was really important for us, so that we could actually start leveraging some of these.
So let me throw a curveball on this, because traditionally we look at data, quantitative data, from sensors, from some KPIs that you're collecting, but there's natural language data, handwritten notes that you may want to interpret for maintenance orders. There's pictures of equipment that you're taking, may have taken in the past. So, for example, with pictures, typically you pre-process imagery, you use specialized cameras to get quality imagery so that you can use that quality imagery to do these AI model trainings for computer vision. Or you look at your natural language data and you realize that there is no consistency in format. So do you still go about getting in the trenches and fixing all that? No. I mean, the artificial intelligence models can train on diverse data sets and still continue to train and essentially learn as they go. So I wouldn't say that the journey to success is to try to fix all your data problems before you deploy an AI model. I think there's incremental processes, and we can discuss, I suppose, further if you'd like to approach us offline.
Loving the conversation, great conversation on the future work in manufacturing. I have a question for you guys. while you're trying to kind of address the problems on manufacturing, trying to kind of really look at how we can come out with a quality process and quality products, how do you envision integration to downstream systems? So for example, I'm dealing with a customer where you have, let's say you have production issues going on, your production line is down, the machine is not working, or the quality of the product is not right. Eventually that's going to impact your demand and capacity to your end products, right, end customers. So how do you envision integration to your downstream systems, and also, which includes finance systems also? Because now you've got this faulty product and you're not able to supply it to your retailers, your finance systems need to change. So number one, my question is, yes, while you're working on this, how are you envisioning impact to the downstream systems, and how we are addressing that?
I think that was directed at me, because you were looking straight at me.
There's no right answer.
We were talking about that yesterday, Justin, so I'm looking at you, but I'll let everybody speak on that.
So this is where I think it's going to be more, AI is going to be more of a supplement to the human portion of it. We still have to have those systems in place where, hey, the AI is down, we need to manually override and get this back up and running so that we can continue to supply that product to the market. That'd be my take on it. So.
Yeah, I think it comes down to supply and demand, like Chris said. You have to still have a human there to make that informed decision to continue Charlie Mike, continue the mission and meet that customer's demands. But as far as specifically to your second question, I think it can tie into a multitude of systems further on down the line once you have achieved that proof of concept with the baby steps, with just focusing on one problem set, that it can tie into the raw material supply ordering. It can tie into establishing a routine maintenance plan for your senior maintenance technicians. And then all those systems talking with one another and hopefully not going towards completely dark factories, but semi-dark factories.
Is the thought there that AI will make decisions and output data, and that data needs to be shared with other application platforms?
That's right, because number one, you're trying to fix your manufacturing problems and really understand the quality of the product. Number two is the data has to go into your integration system, downstream systems, so other decisions are taken in the organization, like finance decisions, invoicing, and your supply chain to your end users or end customers or your distributors.
I would think, you mentioned something on data governance that is relevant into this point, right? Like being able to understand what the data is, what the decisions are behind why certain AI outputs came about, and trusting that so that it can be passed along to other enterprise platforms.
Yeah, I think a lot of that comes down to kind of going back to the keynote, which is trustworthiness, right? So some of this information is really important. So, there are a few things that's a multifaceted question. But I think when you're talking about taking this information from downstream and using it for financial decisions, whether that's routing or capacity planning or whatever the case is, that information, you need to be able to trust it. And if something is going wrong downstream, if you have a failure downstream of some sort, and you're getting bad information and you're making bad decisions off this bad information, that comes down to trustworthiness. Can you actually trust these systems that are downstream that are coming up? And we actually do some, in our case, we actually do checks on our data quality. And we'll take parameters of this information and what we would expect to see from that information. And if things start going south, then we'll get alerts on that information and stuff. So that's a very important aspect, and I think that's something that, especially when you're setting this stuff up, is important to think about, which is the trustworthiness of this information, especially when you're making decisions off of it. So, but that's a good question.
And I do think a lot of that can be integrated into both the upstream and downstream processes, where they can talk to each other, set those scheduling for products that are going to be coming out, so you know the supply ahead of time. And you can communicate to your distributors that, hey, our upstream processes are having issues, or we're having issues, so we may not be able to make that exact profile of products. So you can communicate that well ahead of time as well.
I also think that, it's like the same concept of a calculator. if you ask anybody in this room to do the square root of, pi r squared, no one can do it. But you have a human that can input it, and it's a second independent check. So having a second independent check like Eli is pointing to is, I think, crucial part of the system. Like, we're not going to have an over-reliance on technology because technology can fail.
I was going to give you the square root.
Okay, send it.
A question to basically all of you is, do you really distinguish between what Konrad was speaking about, natural languages, computer vision, augmented reality or mixed reality, versus causative relationships which are established through and validated through statistics, which you were talking about, data cleansing and ensuring that we have cleansed data to make a relationship make sense, versus getting an output which really cannot clearly define a causative. Do you distinguish between the two, or do you club together? How do you sell one versus the other?
Well, I think, I guess we're here for AI and not data analytics. And so I would think, I suppose that the process and approach to data that traditionally is not consumed by traditional data analytics is fundamentally different than looking at quantitative data. But it is also fundamental. The vision of what it's supposed to be used at, where it can take quantitative data alongside with natural language data, alongside with imagery data, and together provide output that gives me insights about my operation, then at the end of the day, it's just different types of data.
I think it's like a tertiary
sense versus getting an output which really cannot clearly define a causative. Do you distinguish between the two, or do you club together? How do you sell one versus the other?
Well, I think, I guess we're here for and not data analytics. And so I would think, I suppose that the process and approach to data that traditionally is not consumed by traditional data analytics is fundamentally different than looking at quantitative data. But it is also fundamentally the same in terms of the general approach that you need to take to be able to get clean data, right? So I distinguish it. Operationally, I don't know if I don't want to speak on their behalf, but I do distinguish the approach differently. But if I'm going to use AI as per the vision of what it's supposed to be used at, where it can take quantitative data alongside with natural language data, alongside with imagery data, and together provide output that gives me insights about my operation, then at the end of the day, it's just different types of data.
I think it's like a tertiary objective that you're trying to seek. So I obviously want to solve one primary objective, and if there's a bonus with a tertiary objective that it's solving, great, but it's not my sole purpose.
Right. Do we have any other questions? Yes, sir.
You guys talked about some of the challenges with getting buy-in and trying different solutions. So how do you balance, there's so many solutions out there, all sorts of technology, some of it very new, placing multiple bets, trying lots of things, versus choosing maybe one thing to go very deep on or place a bet in within your organizations?
That's a great question. I guess I'll take this one. So yeah, good question. So for us, it kind of depends. What I found happening, okay, so there are a lot of different moving pieces within the organization, right? I mean, maybe I'll use us as an example, which would be maybe in Europe, we're using one system for our cloud storage and our cloud computing, and in North America, we're using a completely different one, and South America has a different one as well, and we're kind of all over the place. I think having a really good use case is important. Finding somebody that's doing it and utilizing it well, regardless of necessarily what the best platform is. So, and I guess I should explain there a little bit. So, when choosing between different platforms and technologies to use, for us in particular, it was finding one that we could actually leverage best for us, even though it might not be the leader per se for that segment, but we're able to actually utilize it. We have use cases and proof of concepts that are actually working already. And we're able to take our other divisions and actually implement that technology within to those regions. So that is one of the key aspects when determining what we're going to use. And then as far as finding new technologies, it's kind of funny. It comes in all forms of shapes and sizes. So like, I'll give you an example. We had an intern come in the other day. And interns are great. They really do. They bring very interesting, perspectives on things. And so they actually brought in a technology that we weren't using or leveraging at all. And it was like, this is fantastic. I mean, this is good stuff. This is stuff that we can actually see ourselves using, and created a proof of concept. And now it's something we actually leverage. So, as far as getting ideas and figuring out what technologies are going to work for you, they come from all over the place, but really just keeping your eyes open, I think, is the best thing you can do there, and doing some research and finding people in the field that are already doing what you're trying to do, and reaching out to them and seeing how they leverage it. So, good question.
And I would completely agree with him. When we're trying to implement our condition-based monitoring, there are so many technologies available out there. So my leads and my managers who work underneath me, I had them bring their case scenarios to me, provide a risk and cost-benefit analysis for each one, and we kind of narrowed that down to a few select, and then I would get involved and have a little bit deeper discussion with those various companies, those technologies, kind of see where it would make the most sense with which product we'd go to. So there is a lot out there on the market. You just have to pick the best one that suits your needs rather than taking the most expensive or the best one that's available, because it might not suit you.
This to me speaks like digital transformation maturity, and having frameworks to be able to bring innovation to your organization depending on where you are and how you can scale it. But I would ask all of you guys, is it harder to bring a technology, an AI? Let's say AI is a little different because you're kind of dealing with discrete offerings where the platform holistically isn't necessarily all that available. There are some, but there's not a lot. So you may not be dealing with established frameworks, but let's say you've already adopted AWS cloud. Is it more difficult to bring Microsoft Azure AI services to the doorstep as the go-to option? Like there's more hurdles to jump, more justifications to do, or does that not apply for artificial intelligence?
I think there's a balance, and talking what Eli and Chris said, and based off the first question that was asked, I think it's a balance of tactical recon and collaboration. You have to know where that balance is between collaborating with like industries and other industries that may have a similar problem set, and then doing your own market analysis and market research and recon of available technologies to consumers, because the technology that may be available to you may not even be available to me because you have a partnership with a certain agency or a certain company. And it can be different across the entire spectrum, which is why I think the collaboration is both good and bad.
And Konrad, you brought up a really good point, which is being able, the migration of these services is really important. It's something to consider. You're talking about using some of the AI technologies from Microsoft, or trying to transition to AWS, or vice versa. That's really important. I think that's a really important factor depending on what you're trying to do and what you're trying to accomplish. But looking at the ways that you can actually migrate this technology and move it around, I think is really important too. Because some of these systems and models that you have set up might work in this platform, but if you try and switch them, it's not going to work.
I think we're coming up at the end. So I'd like to thank everybody for attending today.